Hi, and welcome to this video on sigma notation, part 1, brought to you by the Answer series. Sigma is a very important symbol, and every time you see this symbol, you are going to be adding. So if you have a look at the Greek letter, it looks like a capital S in Greek. We are going to recognize that that symbol tells us to add. We can't add unless we are told what to add. So every time you get sigma notation questions, you will be given a formula or asked to find a formula. And using that formula, you will generate the terms that need to be added. Again, you can't do that unless you know what you're substituting into the formula. So you will notice that you are told to start with n equal to 1, and you will end with n equal to 5. And when this notation is given, you go from the start value, in this case 1, you increase by 1 each time until you get to the end value, which is 5. So there are 5 substitutions. In this case, the number of substitutions is identical to the value at the top of our sigma notation sign, but that is often not going to be the case. So don't be misled into thinking that it's always that easy. All right, once you've substituted, what do you do next? You simply work out all of those values in their simplest form, and you add them together, and the sum of all of those terms is 45. I want you to pause the video, try this question on your own, and then we will go through it together. To work out T1, you have a formula given. You are going to take the formula, you are going to substitute the first value that n has to assume. So you're going to substitute minus 2, and you're going to end up with minus 10. There's no conflict because minus 2 is not the position value, it's just the substitution value. So it is very important to notice that the position the term has does not necessarily correspond to the value that you're substituting. So when minus 2 is substituted, term 1's value is negative 10. The number of terms in this particular series is not as easy as in the earlier example. The number 3 has nothing to do with the number of terms. So you have to count the values you're substituting. So you're going to substitute minus 2, then minus 1, then 0, then 1, then 2, and then 3. So now it is easy, at a glance, we can take this and say we have 1, 2, 3, 4, 5, 6 values. So there are 6 terms in this series. That is too long-winded to be sustainable in a difficult question. So the formula that we will use is the top number, which is 3, subtract the bottom number, which happens to be negative 2, and then add 1. Top number minus bottom number, add 1. In this case, 6. So there are 6 terms in the series. In expanded form, we are going to substitute minus 2 into the formula. So I'm going to show the steps. Usually we would just put the answers down. 5 times minus 2, then you increase that by 1. So 5 times minus 1, increase by 1. So you get 5 times 0, then 5 times 1, then 5 times 2, and eventually 5 times 3. If we simplify that, we get minus 10, minus 5, plus 0, plus 5, plus 10, and plus 15. When you're adding something like this, use common sense and don't rush in, and look to see if there's anything particularly helpful about the setup. And you should notice that minus 10 and 10 add up to nothing. Minus 5 and 5 also add up to 0. So that leaves us with a lonely 15, and the answer to this is 15, and no calculator is needed. If you need to process that more slowly, pause the video, have a look at the details of these solutions again, and then we will have a look at the next question together. Okay, so before we move on, we're going to pause and just have a look at a few of the things we've already discussed. So, firstly, sigma notation means we are adding. Every single time we see sigma, we will add. What are we going to add? We are going to take the formula that we're given. We're going to make sure that we know what the start value of substitution is, what the end value is, and we are going to generate the terms that need to be added. So, for term 1, we are going to substitute minus 3 into the formula that they have provided and get minus 7. Then we are going to take, for term 2, the next integer after minus 3, increasing in size by 1, is minus 2. We are going to work out the term 2 value by substituting minus 2 into the formula, and we will get minus 5. And so we continue until eventually we get to the last term, which is the 6th term. Now we have a value of 2 to substitute, and when we substitute 2 into the formula, we get 3. Those are the results that we will add: 7, minus 5, minus 3, minus 1, 1, and 3, if we wanted to work out this result. Again, you will notice that there's some symmetry involved here. So we could add this very quickly because minus 3 knocks out 3, minus 1 knocks out 1. So if we were asked to work out the result of this particular sigma notation question, the answer would be minus 12. The substitution value is not necessarily the same as the position of the term, and that is really important to process. And then one more look at how you calculate the fact that there are 6 terms. You take the top value, subtract the bottom value, and then add 1. So in this particular case, 6 terms. Pause the video, and when you're ready, we'll go through the answer together. You had to start with a substitution value of 1, and you had to continue substituting 2, and then 3, and then 4. Simplify each term, add them together, the answer is 20. Look carefully at this because it looks similar to the previous question, but you are now working with 2 to the power of n. Pause the video, try it on your own, and then we will go through it together. Take your time in a more difficult question, so very carefully substituting 2 to the 1, then 2 to the 2, then 2 to the 3, and then 2 to the 4. Remembering that the exponent is the number of times that the base is multiplied by itself. So 2 to the 1 is 2, 2 times 2 is 4, 2 times 2 times 2 is 8, and 2 times 2 times 2 times 2 is 16. Add the results together, we get 30. Pause the video, do the question on your own, and then we will work through it together. This time, n is the base of the statement, so when we substitute, we are putting in a new base each time. 1 squared, then 2 squared, then 3 squared, then 4 squared. So 1 plus 4 plus 9 plus 16, add all of that together, and you will get 30. Do this question slowly because you have a negative exponent and negative values to substitute. And when you've had a chance to try it, we will go through it together. Okay, so I'm wondering how you did here. Careful, systematic approach. Substitute minus 3, and remember that you have a negative in front of the minus 3. Substitute minus 2, keep the negative in front. Substitute minus 1, keep the negative. Substitute 0, keep the negative. Now you don't have a negative term to substitute, you just have a negative in front, so you still end up with that negative answer. Okay, 3 to the 3, if you simplify the double negative, 3 to the 2, 3 to the 1, 3 to the 0, and then on the end you have 3 to the minus 1, which is the same as 1/3. 3 cubed is 27, 3 squared is 9, 3 to the 1 is just 3, anything to the 0 is 1, and we have 1/3. Careful addition gives us either 40 and 1/3, or if you prefer, 121 over 3. All right, this is our last question in this video. Take your time, make sure you get it right, and then we'll go through it together. Okay, we need to think a few things through before we start. The first thing we're going to think about is how many terms we have. So we have 4 minus 0 plus 1. So we have 5 terms. Remember, the top number is not necessarily the number of terms that we are going to have. When we substitute into a fraction question, we need to keep our head and remember that we are substituting into 2 different sequences because we have the top sequence where we have 2 times 0 and the bottom sequence 2 to the power of 0. Then we have 2 times 1 divided by 2 to the power of 1. 2 times 2 divided by 2 squared. 2 times 3 divided by 2 cubed. And finally, 2 times 4 divided by 2 to the 4. Take your time. Simplify the top and the bottom independently. So the numerator is 0, denominator 1, because anything to the 0 is 1. 2 times 1 is the same as 2 to the power of 1. 2 times 2 on the top is the same as 2 squared at the bottom. 2 3s are 6, but 2 cubed is 8. 2 4s are 8, but 2 to the power of 4 is 2 times 2 times 2 times 2, which gives us 16. Simplifying those values gives us much easier terms to work with. If we add everything together, we end up with 3 1/4 or 13/4. I hope you enjoyed your first experience of working with sigma notation. It really isn't a very difficult notation once you get used to it. Thank you for watching this video, brought to you by the Answer series.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer series, your key to exam success.